Hello everyone, we have another set of notes again. This time we're going to be solving polynomials that we are in when we are in quadratic form. So just to give you a heads up that just because we are in quadratic form, this does not mean that you're going to actually be using the quadratic formula. When you guys start getting into higher level math, you might be hearing this as u substitution. So I'm also just kind of giving you a little glimpse, a little introduction to u substitution, which is also called quadratic form. So I just wanted to give you guys a little introduction just so we can kind of see what we're working with here. So what is a polynomial in quadratic form? This is an expression that can be written as, this is going to sound a little funny, AU squared plus BU plus C. So it's almost like our standard form, but now we have U's instead of the X's. So this is technically where U is some expression in X. So this is an expression that can be written as A of U to the, or A times U to the second power plus B U plus C. Okay, so we're going to be working with these different examples here, and let's actually head over to our first example. So for our first example, we are going to be using our u substitution with x to the fourth power plus 3x squared minus 4. So what we're actually trying to do here is this exponent right here, we are trying to figure out what half of that is. So that middle exponent has to be half of that first one in order to actually use that. Let's make a note of that. So this exponent needs to be half of this exponent. Needs to be half of, and that this exponent was here. Okay, so this exponent needs to be half of that one. Okay, so when we actually go to rewrite this, this is what we're going to see here. So when I rewrite we're going to see that we're going to let u, so you always want to state what u is going to represent. So in my case, I'm going to have let u represent or equal x squared. Once I have that, I'm going to be plugging in the x squareds into my formula here. So when I go to here, let's have u's. So my original formula, we'd have to kind of break it down. So if we have x squared here, oops, sorry, we're in the wrong spot. So if I have x squared here, I'm missing actually two more values. So I have to make sure, two more x's. So 2 times 2 would get me 4. Then I have my 3, and since I already have an x squared here, and then my minus 4. So I'm just showing you where I'm going to be plugging in that u substitution for. So now that I have, so these, we're just showing you that where I'm going to be plugging in my u's, because I'm going to let u equal x squared. So it's a lot of rewriting these different things. So what I'm going to do is have u squared, because the u got plugged in for just the x squared, and then I had the squared up here come out as well, or come to that u. Then I have my 3, this is just going to be u, and then minus 4. So we would rewrite that with no parentheses. So u squared plus 3u minus 4. So I'm just trying to get you guys to look how to rewrite this. So basically, if this is half of it, that's what I want my u substitution to actually be. So when I plug in it's always going to probably be u squared, not always, but it'll probably be u squared and then your regular u. So now it looks like a polynomial that we are used to working with in standard form. So that was just rewriting it, you guys. I just wanted to get you to see how to actually write those things. The next thing that we're going to do is I'm just going to show you an example where we have x to the fourth power plus 5x plus 6. So this is our example here. So again, when we wanted to make sure that this exponent right here, which is the little invisible 1, is half of this exponent here. But 1 is definitely not half of 4. So we are actually this cannot be rewritten in quadratic form. So let's make a note of that. Since this exponent is not half of this exponent, then we cannot rewrite in quadratic form. So then we actually cannot use our u substitution. So it does actually have to be half of, this one has to be half of this one. So that's just the example there. So I just want to make sure, since it's not half, you cannot be rewritten in quadratic form. So for examples that actually can be rewritten in quadratic form, we are going to use our next example. So we are going to solve, make sure you are writing the original example down first so we're not confused at where we started or began our work. So minus 21x squared plus 3, and this is going to be set equal to 0, so that means we actually are going to be factoring and identifying our x values. So when we go to actually look at this, we're going to see that we are solving 18x to the fourth minus 21x squared plus 3. No matter when the only reason I know I'm factoring is because it's set equal to 0. The very first thing when you're factoring, you are going to determine a GCF. So I do see I have a 3 here as my GCF. They do not all have x's, so I'm going to factor out my GCF of 3, leaving me with 6x to the fourth power minus 7x to the second power plus 1, still equal to 0. And then we're going to do something a little different to where we're actually solving. We need to actually divide out our GCF here because we want to end up working with just our polynomial here. So 6x to the fourth power minus 7x squared plus 1. 0 divided by 3 is still 0. So now I'm going to be working with the u substitution of this polynomial. We are now going to let my x be, we're going to double check first of all, is this exponent half of this exponent? And it is. So we could actually use our u substitution, so we're going to let u equal the half one, the x squared, and I'm going to plug in a u anywhere that I see an x squared. Here we have to double it though, so we're going to have our 6x, sorry, let me back up, we're plugging in u, and this one has to be squared because then that will get me x squared times 2 will get me my x to the fourth, minus my 7u plus 1 equals 0. So from there I'm going to, I already took out my GCF, I have 3 terms again, so now I'm going to be using my AC method over here on the side. So 6 times 1 is 6, negative 7 goes as my b value. I'm trying to determine two values that will multiply to 6 but then add to a negative 7, so these actually have to be both negative 7, negative 6 times negative 1 is negative 7, and then negative 6 times negative 6 times negative 1 is positive 6. Negative 6 minus 1 is a negative 7. So my new b values that I'm going to be plugging in, I have 6u squared, and we're going to use the u just like we would with an x. I have my minus my 6u minus my 1u, and then we have our plus 1 that we bring down again. So just like our regular factoring, we're going to be doing our factor by grouping. I have a 6u as my GCF that's going to come out, leaving me with the u minus 1. Don't forget that negative 1 there, you guys. If we were to distribute back, we would not be able to get back to our final answer. And then my leading coefficient is a negative, so I'm going to factor out a negative 1, which means a negative divided by a negative is a positive. Positive divided negative is a negative. What both of these terms have in common here, they have a u minus 1 as their GCF, and their remainder would be this 6u minus 1. Again, we set these equal to 0, and now we are going to solve both of these by setting them equal to 0. So u minus 1 equals 0. I'm going to add 1 to both sides, and that leaves me with u equaling 1. Just hold on 1 second. We're going to end up plugging in our other value of our 6u minus 1 equaling 0. We're going to add 1 to both sides. I'll show you when we plug in 6u equals 1. We have to still divide by 6, leaving us with u equaling 1/6. So now that we have solved for our u's, we are now going to plug the x squared back in. So I'm going to go ahead and erase this, make sure that you guys pause the video so you guys can see where you are. I'm still on this example, I just have to make some more room for myself. So we are now plugging in u equaling 1, and we're left with u equaling 1/6. I'm going to plug in that x squared back into my u. You always have to plug it in at the end. And I have equaling 1, x squared, equaling 1/6. Okay, so now our x is not by itself again all of a sudden. In order to get rid of this exponent of a 2, the reciprocal of that is actually square rooting both sides of our equation here. So square root and the squared are actually inverse operations of each other, which will cancel each other out. And we get x equals, anytime we add this square root to something, our answer is always going to be a plus or a minus of the actual square root that we took. So we have an x equaling a plus or minus 1. Here these will also cancel out, and now we have an x equaling the square root of 1/6, and this is a plus or minus still. However, I don't know if you guys remember from radicals, we cannot, when we actually go to take the square root of these, square root of 1 is 1, but the square root of 6 is not nice. We cannot have a radical in that denominator, so you need to multiply both the numerator and denominator by your actual radical in that denominator. So then we multiply straight across, leaving us with x equals plus or minus root 6, and then root 6 times root 6, or 6 times 6 is 36. The square root of 36 is 6. So now we have a plus or minus the square root of 6 over 6. It's a large problem, you guys. It's a little refresher of radicals as well. Let's go on to our example 4, and we're going to do a very similar example again. This time our example that we are working with is going to be a negative 15x to the 4th power plus 18x squared minus 4. So again, I'm going to go through and double check that I have a GCF. I don't have any numbers in common, and I don't have x's everywhere. However, my leading coefficient is a negative, so I am going to have to factor out a -1 as my GCF here. I do not want to be working with negative coefficients, so that means it's going to be changing the signs of each of those values. So I should have a positive 15x to the 4th power minus a 18x squared, and that 4 is going to turn positive since we factored out a negative of it. We are going to set these equal to 0 as well. We're going to divide out our GCF, and that means that we are left with our 15x to the 4th power minus 18x squared plus 4 equaling 0. Now I'm going to go ahead and determine my u substitution, making sure that this is half of this exponent, and it is. So I actually get to let u equal x squared again. And now I'm going to go ahead and actually substitute in all of my u substitutions. So we should get a polynomial again. Minus 18u plus 4 equals 0. I already took out my GCF, so I have 3 terms. I'm going to be using my AC method again. So if I get 4 times 15, I get 60. My B term is a negative 18, trying to figure out two numbers that multiply to 60 but add to negative 18. negative 5 and 12, but it has to be a negative 12 as well. So now I can rewrite my polynomial here with my new b values, so minus 5u minus 12u, and then we have our plus 4 still. Again, I'm going to determine my my GCF for my first two terms. So I have a 5u that I will be taking out, and I am left with a 3. This is a 1 right here. So 15 divided by 5 is 3. I still have a u left over, and 5u divided by 5u, there's a negative there, so it's going to be a negative 1. GCF of my last two terms is a negative 4, and I have a positive 3u, and then 4 divided by negative 4 is a negative 1. Again, this term and this term both have a 3u minus 1 as their greatest common factor, and left over would be my 5u minus 4. And these are each equal to 0, so I'm going to solve each of these equal to 0 and solve for u. So I have to add 1 here, add 4 here, and then I have 3u equals 1, and I have 4 equals a negative 1. Oh, sorry. No, I don't. I have a 5u equals a 4. We're going to divide both sides, divide everything, 3 here, 5 here. So then now when I go to rewrite this, I'm going to have, this is where I'll be substituting my x squared substitution back in. So I have u equaling 1/3 on one of them, and u equaling 4/5 on the other one. I'm now substituting my x squared back in for my u substitution. And x squared here. And again, we have to take the square root of both sides of everything in order to get rid of our x, or to get our x by itself. So here I have an x equaling a plus or minus the square root of 1/3. We can take the square root of 1, which is 1, but then taking that square root of 3 again, I'm going to have that radical in my denominator, and we cannot do that. So this is the divided by 3. This is where I'm going to have to multiply by 3 over 3. Leaving me with my plus or minus square root of 3 over 3. So again, don't forget your plus and your minus. I just wrote an equal sign there, but this would be my final solution for that one. And then I'm going to erase, give me some more room so I could finish just solving this one. So again, if I went too fast, go ahead and slow down, rewind. I'm just going to solve for my x for this one. So once I have my 5 over here, the square root of 4 is 2. So I have x equaling a plus or minus 2. But then we have the square root of 5 again, and I can't have that, so I have to multiply both the numerator and the denominator by that square root of 5. And then that will leave me with x equal plus or minus, and then we have, see how our 2 is here? It's going to be 2 root 5 divided by 5. So we have our two solutions on that. The root 3 over 3, and then the plus minus root 3 over 3, and then our plus minus 2 root 5 over 5. Alright, you guys, our last example will hopefully be a little bit easier. We'll see. We have an x to the 4th power and plus 8x squared plus 15 equals 0. So right away I'm going to look for my GCF. I don't have a GCF, so I don't have to worry about dividing that out. This exponent is half of this one, so I am going to let my u equal x squared again. Once I have the x squared in there, I can actually substitute in. So u squared plus 8u plus 15. And then again, this is something that we can actually work with. When we have our 3 terms, no GCF, we're going to use the AC method. We get our 15 up top here, our 8 down here, two numbers that multiply to 15, but we'll add to 8. We get our 5 and our 3. We are going to use our u squared. write out our new b values, 5u and a 3u. Bring down our last term of our constant equaling 15, and then we're going to set it all equal to 0. We are then going to determine our GCF of our first two terms, making this a u and then u plus 5. And then our GCF of our last two terms is a positive 3. Make sure you're using that, positive 3. 15 divided by 3 is 5. And now this term and this term both have a u plus 5, which is our GCF. And then our other remainder is our GCF, so 1u plus 3. Once I got down there, I'm going to now solve each of these and set them equal to 0. And then this is when I'm going to solve them, getting u by itself, and I have u equaling a negative 5 and u equaling a negative 3. Now I need to substitute my x squared back into both of those equations. So I have an x squared equaling a negative 5 and an x squared equaling a negative 3. Taking the square root of both of those, all of them, the square root and the squared divide out or cancel out. X equals a plus or minus the square root of negative 5. And just to give you a heads up that since we have a negative in the radical, I don't know if you guys remember that, we can't take the square root of 5, but just something to actually remember is that the square root of negative 1 is equal to I. So that's what that negative is going to come out as, and so we have an x equals a plus or minus I left over with our square root of 5 that we are unable to simplify and take. So that is one of our solutions. Our next one here, we get our x equals our plus or minus the square root of a negative 3, and then again that negative 1 times 3 is a negative 3. So now I have my x equaling, and it's going to be our plus or minus our I, then this time we have a square root of 3 instead. So those are our solutions. Those are our imaginary solutions. We have covered imaginary. We have covered simplifying our radicals, where we can't have a radical in the denominator for both of these. We've also seen when we aren't unable to actually use our where we can't use our u substitution to make it a polynomial to actually factor, and then I showed you guys how to rewrite it. I just wanted to go over one last little thing. Does the quadratic form mean that you actually need to use the quadratic formula? I'll let you guys answer that when I see you in class. Thank you for now. I will see you next time.